Welcome everybody to the second video in this series. Today we'll be talking about the prescriptive versus performance and those changes. I'm Kent Pearson, a registered energy advisor and journey person carpenter.
Hi, I'm Daryl Paul, and I'm involved with energy efficiency and building envelope as well. So we're going to try and help you understand the difference in the new codes between prescriptive and performance. So when we think of prescriptive versus performance, one of the things I always think about is what's the difference. So we're going to break that down and say, for instance, when you're doing an addition, what are you going to use? When you're doing a house with lots of glass, what are you going to use? Performance or prescriptive? So really, performance is taking the whole package, the whole bundle, and putting it all together, and then saying what's the energy usage compared to the model that you're doing for reference. Whereas prescriptive is pretty rigid because it's X in the walls, X in the roof, X in the windows. And you do have some work, or you do have some ability to get those conservation points to adjust it as we move up the tiers. But what does it all mean? So that's what we want to answer in this video.
In the video today, we're going to cover the differences and changes between the prescriptive path and the performance path, as well as go into the new tiered performance prescriptive and tiered performance paths.
So as Kent mentioned, we're going to be discussing the prescriptive tiered code. So first of all, the thing to remember is when we start, Tier 1 really doesn't have any changes to it. Now that is apart from a couple basic things. For instance, you will require an HRV if you're doing prescriptive. Now one of the other changes is the fact that the trade-off has been changed from the trade-off, traditionally what we knew, into a tier. And so we'll discuss that in a minute, what that means. But basically, we're still dealing with a table that tells us X in the wall, X in the roof, X in the windows. So it's fairly rigid in terms of how we put that together, and it determines exactly how we're going to insulate that building. And remember, when we're doing prescriptive, we're a little bit limited in what we can do because we have to follow those tables.
And when we think about those tables, those are the same tables that we've been using from the 2019 Alberta Edition National Code. They're still the same lineal requirements for our walls, roofs, floors, foundations, and windows.
The one thing that you will notice when you go through it, though, is there's some minor improvements. For instance, remember when we were required to ensure that we had the maximum amount of insulation even when we put a vent pipe in the wall? That has been removed, which is very, very good for us when we're building in the field and for doing the energy modeling in the first place. But so some of those little tweaks will benefit us. So when we're talking to our energy advisor, he's going to give us that information and tell us where the changes are, so we don't have to just go through and dig them up ourselves. The energy advisor that you've hired can provide that documentation or information for you. So we've been talking about tiers, and they're not those kind of tiers. It's the levels that we talk about within the code. So there's 5 levels or 5 tiers. Now when we start at 1, there's very limited things that we have to change. Once we get to 2 and then progress to 3, 4, 5, now we have to gain more points to be able to achieve the levels we want. And those points are based on getting more insulation into the walls, improving the envelope. So when we get more points and we improve the envelope, that's the direction that the tiers are going to take us. So with the tiers then, we're going to start with Tier 1. Now the main thing with Tier 1 is we don't need any conservation points. We're just at the same level that we finished off with the 2019 code. The one thing that you will find with the new code is that with Tier 1, you're going to need an HRV. So in the older code, we had a trade-off option. In the newer code, there is no trade-off. We have tiers that we follow, but the main thing, if we're on Tier 1, is no HRV. Now, I understand there's another thing with the percentage of glazing per face.
There is, and the change that occurred goes back to that conversation you may have heard us talk about in the first video of overheating our homes and the solar heat gain in glass. What they've added to that tiered prescriptive is we are no longer allowed to have more than 17% glazing in a facing direction and use an energy rating to show our energy compliance for our windows. It forces us into a U value to reduce the risk of overheating.
Right, and if you remember the energy rating, maybe people don't remember what that is, but you have the option to go with a U value and a solar heat gain, or an energy rating. And so the energy rating is calculated based on some of that performance criteria like U value and solar heat gain. So you still have that option to go with one number or the other number. So I think the first thing we need to do is remember that prescriptive is covered in 936.2 all the way to 936.4. So when we go through that, we're going to start with the envelope. We're going to break that down. We're going to look at the tables and say, what do the walls require in our climate zone? And then the table's going to break it down into two parts, with an HRV or without an HRV. And then as we go through that table, we'll move from the walls to the roof to the windows. We'll talk about the foundation. But then the next portion is the mechanicals. So the mechanicals, we're going to talk about what's the minimum requirement for heating, for the various energy sources for heating, for electric, natural gas, different things like that. Then we're also going to talk about ventilation, we'll talk about air conditioning, and then finally in that prescriptive level, we're going to talk about the domestic hot water and what we need to do to meet those standards. So prescriptively, that's how the code flows through. Now, with that, the next step that we get into is talking about that question about trade-offs. Is there a trade-off or is there not a trade-off?
What we're going to see as we move into that tiered path is we're going to have possibly multiple trade-offs that will occur. We'll do a trade-off for our entire house, as we've consistently done over the past years, but we may also have one for only our walls or only our windows, depending on the energy conservation points that we're hoping to get from those effective RSI values.
So I think a question that I would have as a builder, if I'm using trade-off today, I'm using prescriptive. So back up a second and say we have prescriptive option, and we have performance option. But if I'm using the prescriptive option with the simple trade-off right now today in the 2019 code, what is going to be affected?
With Tier 1, nothing's going to change for us. The change that we're going to find when it takes us back to 936.2 through 4 is we have those tables that give us with HRV or without HRV. We now no longer get to use that table for without HRV. At Tier 1, we must install an HRV unit.
So with the prescriptive, what's going to change May 1st? So I'm a builder and I'm doing the trade-off. Now I move to prescriptive on May 1st and I'm into the tiered codes. What's going to change there? But also, I remember in prescriptive that it talks about the tables with an HRV and the tables without an HRV. So it sounds like because it's mandatory for Tier 1 prescriptive, I'm not going to be able to use those tables. Is that correct?
When we're looking at trade-off in the tiered prescriptive path, that still remains. The difference that we will see is we may see that trade-off that we've been doing for the whole house to ensure that it will still comply, but as we move into the tiered prescriptive, we may see two different trade-offs that will occur. We'll have the one for the whole house, and then we may see one for just the walls and one for just the windows.
So what you're saying is that the original that we're working with now, 2019, is called a simple trade-off. The new one isn't quite as simple, even though in Tier 1, there's not a lot that we need to do with it.
So you're correct, Errol. It is still that simple trade-off that we're going to see. We may just have more calculations that we have to do, but it's still that simple trade-off path.
Right, so that's where the energy advisor comes in. Now with performance, it used to be you sent it out to them. Now with the prescriptive, you might engage an energy advisor to get involved with that. But the other question I had with regard to the code section with prescriptive is, what about the HRVs? Because I noticed the table will include HRVs and then without HRVs. So now how does that affect us with the prescriptive path in Tier 1. So then with the prescriptive requirements, my question is, what do I need to do for compliance when the code takes effect?
When we comply with 936.8 tiered prescriptive, the change that we're going to see is HRVs will become mandatory, even at Tier 1. So Tier 1 takes us back into 936.2 through 4 for those effective values in our walls and roofs, but it removes the requirement for those tables. We now have to meet the with HRV table, not the without HRV table.
So in preparation for compliance with 936.8, what do I need to do?
When we're going to comply with 936.8, we're going to see mandatory HRVs be installed. We're going to look at that peak cooling load conversation of 17% fenestration in facing directions, as well as we're going to talk about those ECMs, energy conservation measures, that are required for each tier.
Okay, Kent, so we talked about the energy conservation measures. So that's what you're referring to when we talk about ECM. So maybe fill us in on what that really talks about.
Our energy conservation measures in the prescriptive path focus mainly on the building envelope portion. We're going to be able to get points for increasing effective RSI values in our walls, our below grade assemblies, our windows or doors. We're going to see points for our air tightness. And there are also some points for HRV efficiencies, some domestic water heating efficiencies, and for volume.
Exactly. So as we move up the tiers, we're going to need more conservation points to achieve a specific tier. So for instance, if we were to look at the table for walls, in a zone 7A, such as we're in, walls for a 2.97 RSI give you 0 points, which is the standard metric for a minimum wall assembly. But if you move up to, for instance, 3.08, then the RSI value for that gives you 2.1 points. If you go to 3.61, then you get an additional point. So once you add these all together for all the walls, all the windows, all the foundations, you will come to a number of conservation points or energy conservation measures that will help you to achieve whatever tier you're shooting for, whether that's for the compliance of the code or whether that's just improved energy efficiency. So having said that, if we have something in the middle of the table, for instance, if I'm at 2.97 and I jump to 3.08, I get 2.1 points. But what if I want to go just halfway? Say I go to 3.02, can I just use the middle and average the points?
As of right now in the building code, there is no interpolation between the points. We only get the points awarded for the effective RSI value that we have met. With that, in your assemblies, if you have some that are 3.02, but you have a number of them that are above 3.08, we can look back at that trade-off assembly for our above grade walls to say, with that trade-off, do I meet the overall energy usage, in which case I am then allowed to use that 3.08, proving I have assemblies that are better that make up for that 3.02.
Good, so as long as I remember to make sure I use the lowest point of the average, unless I'm doing the trade-off, that means that if I'm building at a 3.02, I'm still going to have to use that lower 2.97. I can't jump to that 3.08 value to achieve those points, so no interpolation.
Zero interpolation.
Okay, so Kent, if I wanted to have some takeaways, what would be the main points for prescriptive compliance?
The top takeaway with a prescriptive path is it is a very lineal compliance. It meets or it doesn't, but there are some homes that benefit from this compliance path.
So now that we've had a good look at prescriptive compliance paths, we can look at performance compliance paths. And with performance, what we have there is more flexibility in how we're able to achieve compliance. Now, when we look at the compliance path, and we look in performance, one of the things we need to understand is how that helps us to achieve that. So you may recall from what we're already doing that we take a house, a proposed house, and we figure out the energy model. In other words, we figure out what we want to use for insulation values in the walls and the roof and the foundation, what the windows are, mechanical. We put that all together and we say, how much energy is that going to use? And then we build a duplicate of that, and we call that the reference house that we compare to. And as long as we're even or better than the reference house, that means we're in compliance. Now, with Tier 1 that we're starting with, when we look at this program, what happens is Tier 1, we start at 0. We're right where we are now before we entertain a new building code. One of the big changes, though, that allows us to move forward with performance is the ability to now incorporate EnerGuide as an even playing field. So the difference between incorporating EnerGuide is that we do the same thing, but now we have to do a final blower door test. So prescriptively, on the EnerGuide program, we have to do a blower door test as part of that program. So with performance, we can use the prescriptive values for air tightness, but we don't have to do that with the EnerGuide program.
Daryl, you mentioned a prescriptive air change rate. What do you mean by that?
Okay, so when we get into air tightness, we have the option to go to a prescriptive rate, like for instance, 2.5 would be a prescriptive rate, or we can do as tested. Now, with the EnerGuide equivalency, as an energy advisor, you know when we go out and we model a house, we have to perform a physical air tightness test on it. So it's prescriptively required in the program. So when we're doing the air tightness test, it's not so much the number we get, it's that number helps us to achieve the final information in that package. And so the difference between going EnerGuide, having that required air tightness test at the end, or going the performance path, we can apply the prescriptive requirements within the performance path to say we want to use either 3.0 ACH or 2.5 ACH to achieve the value that we're looking for.
Now, Daryl, you gave us two different air change values there. You gave us a 2.5 and a 3.0. When would I use which?
Okay, so that's a really good question, Kent. So to start with, let's clarify what we're doing right now. So right now, the current code, we can use 3.2 ACH, where we don't have drawing details, or we use the 2.5 ACH, where we do have drawing details. One relates to 9.25, and one relates to the 936 energy code. That's about to change because now we've changed so that all buildings are 2.5 unless they're multi-family. So it'll be a 2.5 ACH for single family, but now instead of 3.2, we can use 3.0 for a multi-family. So it's a bit of a clarification, and we'll touch on that a little bit further in our video dealing with air tightness, but that's the two qualifications, is that 3.0 is for multifamily as our baseline, and 2.5 would be our ACH for single family. Remembering that that's the number that we're going to put into the performance or the prescriptive and the reference house.
We just finished talking about the prescriptive tiered. What about a tiered performance?
Well, we don't want to disappoint you. There is a tiered performance. But the good news is that in Tier 1, there's no changes to what we're doing. In fact, the only thing that changes in Tier 1 is the fact that we can use EnerGuide as an equivalency, but we need to move from a 92% to a 95% furnace in the reference house. So those are the two main changes. Now, when it comes to the tiered performance, what's happening is we'll have a chart in there that helps us to understand what we need to do. So for instance, in Tier 1, it's 0 and 0. So in other words, what's the envelope improvement and what's the overall performance improvement? There's two levels that we have to look at. So if we follow through the code and we look at the tiers, Tier 2 means we have to have a 5% improvement in envelope, 10% improvement in overall performance. Then we go for 10% and 20% with Tier 3, 20%, 40% in Tier 4, and 40% and 70% overall improvement in Tier 5. So when we do the calculation and we're looking for the percentage of performance increase, We know when we do a proposed house, we have a number, and we have the reference house, we have another number. The HOT 2000 software actually will give us the percentage of increase based on what the code is asking for. So we have a really good indication right away as soon as we put that data in. Are we compliant? Are we not compliant? And then from there, we just go back and figure out what we need to do to tweak that.
So you mentioned something about building performance and also energy comparisons. Are there two metrics, or is there one metric that we need to meet?
Well, that's a good question, Ken. The two parts to this is the fact that we have to reduce the heat loss by a certain percentage. So that's the top part, that's the building envelope. So we have to use either 5%, 10%, 20, or 40% for the overall building envelope heat loss. The second part of that, which we also have to meet separately, but it goes together with it, is we have to look at the overall performance. So that means when we look at the overall performance, we're including domestic hot water, we're including mechanical, ventilation, all of these things together. So that gets into the higher level of percentage of improvement, where we get into the 10%, 20%, 40%, and 70%. So between the two of them, there is two areas that we have to meet independently, but both are required.
So the way I understand that then is we still have the metric on overall energy usage, which we're using right now, but we've added a new metric to help reduce our overall heat loss within the building envelope.
Yeah, exactly.
So Daryl, when we're talking about the changes in the performance path, are there other changes that would affect how our energy is calculated, even for myself as an energy modeler?
Yes and no. So for an energy modeler, there's a few changes that are going to impact you. A lot of it can be built into the software, but the code reflects it in how it expresses, for instance, internal heat gains. There's a new schedule or table on the internal heat gains. There's a change in how we calculate the hot water usage. Not necessarily the hot water usage, but the efficiency of the hot water usage. We used to use the EF, now we're using a UEF, a uniform energy factor. So those two we need to understand as energy modelers, but as a builder, you won't even notice those things. They're not really something that a builder would have to worry about. The other one that comes up is the temperature set points for hot water and different things like that. So there is a few things that are going to impact the actual energy modeler, and he needs to be aware of those, because if he's not, and the permit documents go in for permit application, and then the safety codes officer picks up on it, he's going to question that. So yes, for the energy advisor, needs to be aware of it. For the builder, won't notice any difference.
In the performance path, we talked about using that 2.5 or 3.0 ACH value, but they had something that says we have to use a 0.067 flow exponent. Can you explain that for everyone?
So I get to nerd out, you mean? So this is kind of interesting. The flow exponent really is a calculation of how much air is going through those holes or those openings. So you, as a builder, you don't need to know it. It's built into the software. The only thing it tells us as energy advisors is if that number is down to like 0.5, it tells us there's thousands of tiny, tiny little holes, and it's measuring the friction around them. And if those holes are up at 1.0, then we've got several large holes. So it helps us to identify if the house is really leaky because just equalized leakage throughout, or whether we have a door open, a window open. Well, it wouldn't be that extreme, but if we have an opening big enough that we could actually repair it and fix it. But what we want to see is an average of 0.67.
So we've covered all the changes that happen in 936.5, performance energy modeling. Are there other changes that occurred in 936.7, tiered performance?
So the only other thing I can think of is the peak cooling loads. And when we look at the peak cooling loads, what it is it's how much heat is coming through the glass of the windows based on the solar heat gain coefficient. So that coefficient really, when it's a high number, lets a lot of heat come into the building. So what we're trying to do is reduce that buildup of heat by implementing that. So the way the calculation is done, we determine what the solar heat gain is coming in, depending on the face of the building and what percentage of glass is on that face. and then we compare the proposed house of what we're building with the solar heat gain and that to a reference house, which gives us the code required values, and if we're equal to or better, then we're compliant.
Daryl, what are the top takeaways when we're looking at the performance path?
Well, the nice thing about the new performance path in Tier 1 is there's not a whole lot for the builder to do. So a lot of the things that are changing are behind the scenes. So the energy advisor, such as yourself or me, will have to do a little bit different calculation for the domestic hot water tank. We'll have to do a little bit of changes when we do the internal gains and things like that. But really for the builder, the only difference would be if you're using a furnace that's different than the 95%, we would have to model that in. But really the takeaways would be that, for a builder, no change.
So we've gone through the prescriptive and performance paths. How do we choose between the two of them?
Well, I think the question I would ask if you were asking me that as a builder is, what are you trying to achieve? So for instance, if you're trying to achieve straight code compliance, then you have those two options. But what if you're looking at building starter homes? Maybe budget is a concern. So it has to be cost effective. So you pick a path that's more cost effective for you. Or perhaps energy efficiency. You want to have better energy efficiency, so that could dictate which path you build. And then finally, what about the comfort? Because the flexibility of the performance path gives you the ability to adjust the comfort as the house is a system. So the first thing we always talk about when we're talking to builders is think about the system that you're building. Think about the energy usage, the energy production, where it's going, how it's being used, and figure out what the overall building is going to do. And then from that point, you can start to break down the disadvantages and advantages of each of those compliance paths.
So when we're looking at those different metrics of why we're choosing a path, when I think prescriptively, some of the advantages are I get to design it one time and use it anywhere in my zone. The disadvantage of that is quite possibly I wasn't taking in affordability into the account or the overall comfort of construction.
Yeah, that's a good point, because if you think of prescriptive, if the prescriptive requirement is an R22 bat of insulation, you wonder, how can I reduce that? Well, if you take the performance and you increase the percentage of efficiency of your hot water tank, of your furnace, maybe change the direction of the house so that you get a little more solar heat gain, free heat in there. Now I can bring that down from R22 to R20. But then the disadvantage of the performance model is, for instance, like you're saying, the direction. So we have one model we do for one builder, and when we model it to face one direction, it's 9% below code. But as soon as we change it 180 degrees because of the amount of glass and what the glass is, we get 25% better than code. So from a performance standpoint, that's a big disadvantage to that builder to do that particular model as a performance. It'd be better to use it as a prescriptive. So if I think of another disadvantage to performance, when you're doing a high performance house and it's got a lot of glass in it, for instance, sometimes we'll get models from builders and they'll have 40–50% glass. They'll have a huge percentage of glass. Now, one of the concerns is the overheating with the peak cooling load, but that aside, you're able to do high percentages of glass with prescriptive where you can't fit those into the performance model. So in some cases, you may want to take that individual model and say, when I model it, is it better to go prescriptive or is it better to go performance? And really those factors that we've talked about really have a big impact on it. So for an individual builder, they want to analyze all their models, look at all their buildings and say, are these just basic starter homes? Are these mid-size homes? Are these upper end homes? Because that's going to help you determine. And even when you're doing some of these, you might choose 2 or 3 models that need to be done prescriptively to fit into the mold. And so that's where that flexibility to use either performance or prescriptive comes in.
And you mentioned peak cooling loads. That would be one space as we're looking into these tiered levels, that if I have a home that can't meet that peak cooling load, maybe I need to bring that back prescriptively. But even in the prescriptive tiered, we now have to install an HRV If we want to remove that HRV, we're going to have to look at doing the performance energy model.
Exactly. So now as we look at the tier 1, it's pretty straightforward. But now when we get into tier 2, tier 3 and beyond, now we have to start getting into more strategic ways of doing that calculation, because now we're getting into the thicker insulations, the more air tightness, the better performance. So at that point, we might find that we go from a performance model to a prescriptive up the tier, or we might find that we start prescriptive and we end up with a performance model. So it's not going to be status quo as we move up tiers. We're going to have to redesign these things sometimes and use the compliance path that's going to be the most effective for us.
An example that I have is I have a builder that wants to build to tier 2. We were looking at doing it prescriptively so we could repeat this home over and over, but we're not willing to make that wall insulation value that we would have to get so we can get those energy conservation measures. So we now move into that performance modeling.
Yeah, and that's what happens, is the only option is to move either from performance to prescriptive or vice versa. And when we think of above grade versus below grade, one of the challenges too is if we're trying to offset energy usage, you know, some of the below grade requirements, depending on where we are, can be relatively high. Whereas with the performance model, if we choose to go that option, we might be able to take the additional insulation, additional values that we've got from other components, and reduce that value in the basement. So again, the flexibility is huge between performance and prescriptive, and it allows us to choose the path that's going to meet our compliance needs.
So we've chosen our path. Now, what do we need to show our authority having jurisdiction that we've met the full compliance? When we're submitting for our prescriptive compliance, we're going to show the climate zone that the house is going to be built in, all the calculations showing the effective RSI values, all the different assemblies within the home, the window U values or energy ratings showing they meet compliance according to those charts, our mechanical efficiencies, as well as our domestic hot water efficiencies showing compliance according to the charts in 936. When we move into the tiered prescriptive, the new information that we need to show is those energy conservation measures and how they were going to be awarded, and any supporting documents or calculations to show how you got to those numbers and awarded accordingly.
So when it comes to the performance model, we're going to be comparing a proposed house with a reference house. So what we need for that proposed house is all the assembly effective RSI values. We need to set the house in the facing direction, which direction the sun is going to hit what components within the house. We'll set the heating degree days, or the climate zone. We'll figure out what the construction assemblies are going to be, and when we apply those RSI values, then we compare that to the proposed house. We need to know the windows. We need to know the solar heat gain of the windows, as well as the USI, or the metric values for those windows. We need the mechanical systems, ventilation systems, and domestic hot water, and the efficiencies of each of those systems. We need to know which ACH we're going to model to. So if our proposed house and our reference house are the same, we could use 2.5 on both of them, for instance, for a single family. Whereas if it's a multi-family, we could use a 3.0 for the reference and a 3.0 for the proposed house. Now when it comes to the fenestrations, or the FDWR, the percentage of glass versus the percentage of wall, we need to calculate the percentage of those areas. And then that is inputted into the energy model as well. And then what that will provide us is an output report that we can put with the documentation that we fill out for the AHJ, the authority having jurisdiction. And within that report, some information will be collected by either the safety codes officer reviewing the report, or we'll place it right on the documents required. And the main component that we look for is the energy consumption comparison. Now, when we move from there, using the 936.5 performance model, and we move into the tiered portion of the code, the 936.7, that's where we have to also now calculate peak cooling loads. So when we do the proposed house versus the reference house, what are the peak cooling loads of each of them? And that determines compliance. And then what is the heat loss calculation specific to the building envelope? So all of the assemblies, or all of the envelope together, what's the total heat loss between the performance of the proposed house and of the reference house? At that point, that's the information we need for compliance to achieve code compliance. However, we mentioned that you can also get compliance by using the Enter Guide. So for the Enter Guide, you're going to require a third party, and the third party will perform all the same information, the data input, provide the reports, but then at the conclusion of the project, just before occupancy, you will also have to do a physical air tightness test, and that number will be inputted into the software, and then that report will be generated with a label. You'll have an Enter Guide label that you can provide to the homeowner, but that information is also provided to the AHJ so that they can verify compliance. And so the benefit of having the understanding of what is entailed in the new prescriptive and performance parts of the code, choosing the compliance path, is that we have now the opportunity to gain the experience necessary as we move to more energy efficient homes. But one note we'll make is a clarification on 936.7 and 936.8. I'm just going to read you the compliance in the current version of the Alberta Building Code, which is going to be effective May 1st. It says there that compliance with subsection 936.7 or 936.8 is deemed to meet these requirements. And when we look at the appendix, it clarifies that, and it says a building is not required to comply with subsection 936.7 or 936.8. So for the time being, we have the opportunity to spend some more time to be able to develop our skills at using the tier code. We don't have to do it as a compliance, but we do have the opportunity now to put into practice what we've learned today so that we can improve in our energy efficiency of construction.
Thank you for joining us. We look forward to seeing you in the next video, and don't forget that free building code.